Hello everyone, good morning. Welcome to the live lecture of Doubtnut. So we were doing our chapter Haloalkanes and Haloarenes. This is the first organic chapter of class 12th and we'll continue with this. We were on the topic of preparation of your haloalkanes. So this is preparation of haloalkanes part 3. Part 1 and part 2 is already uploaded, and in part 1 we have prepared your haloalkanes from alkanes. In part 2 we have prepared your haloalkanes from alkenes, and in part 3 we'll focus on halogen exchange reaction as well as preparation of haloalkanes from your alcohols, right? So this would be the last part of preparation of haloalkanes. Later we'll be dealing with your chemical reactions as well as physical properties of haloalkanes. This is the lecture number 6. Let's move forward. If you don't know me, let me introduce myself to you. My name is Shagun and I've done my masters in chemistry from Miranda House, Delhi University. I've added few qualifications. If you want to give a look to it, you can. Otherwise, we can skip this portion. Let's start, but before that we have one important announcement. The announcement is that Doubtnut is launching, or we can say it has already launched, a new English speaking course, and our top English teachers are gonna take this course. It has already started from 8 July 2021. If you want to join this, there is some information in the link given below in the comment section. You can grab the information and join the course via that link, right? Okay, so what we'll learn today is we'll prepare your haloalkanes. First of all, we'll deal with the halogen exchange reactions, and then we'll do the preparation of haloalkanes from your alcohols. We'll also practice NCERT questions as well as previous year board questions, right? But before that, I'll also give you a quick revision of what all we did in part 1 and part 2 of preparation methods of haloalkanes, right? Okay, so we have almost covered maximum preparation techniques of haloalkanes. First of all, we prepared haloalkanes from your alkanes, and I told you to prepare haloalkanes from your alkanes, you have to undergo a free radical mechanism, and the process is known as halogenation. That is, whenever a halogen is added to your alkane, it forms haloalkanes, and the process is halogenation, and it is done in the presence of a light. It can be a UV light. In questions you might see on arrow a UV light is written, or you can say HNU is written. That means this promotes the formation of free radical, and the reaction process happens via a free radical mechanism, right? For example, if you want to prepare your chloromethane, what will you do? You'll take methane, you'll take Cl2 in presence of UV light, it can be written as HNU, and then you get this CH3Cl. But you also get a lot of side products during a free radical mechanism. You might get CH2Cl2, you might get CHCl3, and you also can form, it can give you C sulfur. You get a lot of mixture of products via a halogenation process in alkenes. We have already understood the mechanism of this process. The mechanism said that it has 3 possible steps. The first step is the initiation step, where your halogen atom breaks down. There is a homolytic cleavage in Cl2 and it breaks down to give you 2Cl radical. This was the initiation step. Then we had the propagation step, where your free radical combined with your alkane to form alkyl free radical. That is, CH3 radical was formed and H radical, Cl radical combined to give you HCl. And then we had the termination step, where all the radicals which are left in the reaction mixture combines and give you the final product, that is CH3Cl was obtained. This reaction can be further continued, further free radicals can be formed, they can combine, and we get mixture of haloalkanes. I've already told you that via halogenation we only form bromoalkanes and chloroalkanes. That is, if you want to convert an alkane to a haloalkane, only bromination and chlorination is a common process. We do not do fluorination and iodination. Fluorination is an explosive reaction, so we do not perform that, whereas iodination is a slow process. We also do not perform that. Bromination leads to the formation of bromoalkane, and chlorination leads to the formation of chloroalkanes. So by halogenation process we can form your bromoalkane and chloroalkane commonly. Now a point is, how do we prepare iodoalkanes and fluoroalkanes? Here comes the role of halogen exchange reaction. If we do halogen exchange reaction, we can easily form your iodoalkane and your fluoroalkane. We'll discuss this later, right? We'll discuss this halogen exchange reaction. It is performed on bromoalkane or chloroalkane, and it leads to the formation of iodo and fluoroalkane. We'll discuss two reactions here. One is Finkelstein reaction, another one is your Schwarz reaction. Finkelstein reaction converts bromoalkane into iodoalkane. The Br group is being substituted by iodine group. So Br and iodine both are halogens. They undergo halogen exchange reaction. Similarly, Br if substituted by F fluorine group, it is also an halogen exchange reaction, right? So this is what we are gonna focus today. We'll be doing Finkelstein reaction and Schwarz reaction, and thereafter we'll do the preparation of haloalkanes from your alcohols, right? So this was the first method. We prepared haloalkanes from your alkanes. Now it was the time for second part. We have prepared alkenes. We have used alkenes in preparing haloalkanes. As we know that alkenes are electron rich substrates. I have explained to you yesterday, that is on Wednesday, that alkenes have loose pi bonds. Alkene has loose pi bond. A pi bond has loosely held electrons to it. So this, whenever a substrate has pi bond, or we can say they have pi bond, we can surely say that they are electron rich substrate. An electron rich substrate will attract to electron deficient reagent. An electron deficient reagent is known as electrophile, and whenever an electrophile participates in a reaction, it always shows electrophilic reaction. I said it always shows electrophilic reaction, that is, it can show electrophilic substitution reaction or electrophilic addition reactions. In alkene, generally addition reaction happens, that is, if we take your, let us say if we take your ethene and you add HBr to it, you will get the product CH3CH2Br. The substrate is electron rich. Electron rich substrate attracts electrophile. Whenever electrophile participates, this is electrophilic reaction, and nothing has been substituted. It is just the addition, that is, the pi bond is broken and H and Br adds to your alkene, which is the substrate. So this is an electrophilic addition reactions. In alkene, we generally observe electrophilic addition reaction. Now also we have here discussed the Markovnikov rule. According to Markovnikov rule, we have discussed that whenever the carbon carrying double bonds are different carbons. In the case of ethene, both the carbons were equivalent in nature because both are CH2, they are almost equal. So if you add H to the first carbon, you get CH3CH2Br. If you add H to the second carbon, you get CH2 here. This is Br added to the first carbon, and CH3, the second carbon, H gets attached to the second carbon, it forms CH3. Both are 1 bromo ethane. Both are 1 bromoethane. So whenever you have equivalent carbons, they are similar carbons, you only get one product. But when we have two different carbons, that is, if I take an example of propene. if I take an example of propene, if you add HBr to it, the two carbons here are different. One is CH, another one is CH2. They are different carbons. These are unsymmetrical alkenes, or you can say these are different carbons. This is unsymmetrical alkene. When both the carbons are same, this is symmetrical alkene. In symmetrical alkene, you get one product. In unsymmetrical alkene, you get more than one product. Right? If I say this carbon as carbon number A, and if I say this second carbon as carbon number B, if hydrogen goes to carbon number A, the product obtained is CH3. Hydrogen goes to carbon A, CH2, CH2, Br. Product obtained is 1 bromopropane, right? But as we know, hydrogen can also go to your carbon number B. Then the product obtained would be, if hydrogen goes to carbon number B, Br has to go to carbon number A. The product obtained will be 2 bromopropane. This is 2 bromopropane, right? Now, which is major? Is 1 bromopropane major or 2 bromopropane major? How do we decide that? This rule was given by Markovnikov rule. We have already discussed Markovnikov rule. According to Markovnikov rule, I gave you that you must remember one line: rich becomes richer. This was my technique to learn the Markovnikov rule. My teacher told me this. You must remember rich becomes richer, right? Now, rich is in what context? If I talk about carbon number A, how many hydrogens does it carry? It has one hydrogen, whereas carbon number B has two hydrogen. The richness is with respect to your total number of hydrogens the carbon carries. Since carbon number B carries two hydrogens, carbon number A carries your one hydrogen, the rich carbon is carbon number B, and it becomes richer if hydrogen goes to carbon number B, right? Rich becomes richer. Carbon number B is richer because it has two hydrogens. Hydrogen that goes to carbon number B becomes more richer in hydrogen. So this product where hydrogen goes to carbon number B is the major product, right? If I see here, this is carbon number A, carbon number B. Carbon number B has Br attached to it. This is minor product because we have to make rich carbon more richer. This is carbon number A, this is carbon number B. It has added, the hydrogen is added to carbon number B and it has become richer. This is major. So this was the Markovnikov rule. You can remember it in this way. You will never forget in your life, right? Okay. We have also understood the mechanism to it. We said that you have to basically break the pi bond in such a way that carbocation formed is more stable. If we break the bond this way, we undergo a heterolytic cleavage this way, the carbon, this carbon will carry a positive charge and this carbon will carry a negative charge. Since carbon carrying positive charge is carbocation, it is a secondary carbocation. Secondary carbocation is more stable. You break the bond in this manner only. We have already discussed it. So Br minus goes to this and H goes to this. We have discussed this with mechanism. So this was normal Markovnikov rule, that is addition of HBr, normal HBr to your symmetrical and unsymmetrical alkene, right? So in unsymmetrical alkene we get two products. One is major, another one is minor. Major is decided according to Markovnikov rule. Measure is decided according to Markovnikov rule, that is rich becomes richer. So this was addition of HBr, a normal addition of HBr. Now we have to do addition of HBr in presence of peroxide, and this is very, very important. In this we will be studying about anti-Markovnikov rule. We will be studying about anti-Markovnikov rule. Anti-Markovnikov rule is just opposite to Markovnikov rule. According to Markovnikov rule, as we know, rich was becoming more richer, was becoming more rich, Rich was becoming more rich, or rich was becoming more richer. Rich was becoming richer. If we are using richer, we don't have to use more. Rich was becoming richer, right? Okay. So that is hydrogen goes to, according to Markovnikov rule, hydrogen goes to the carbon which is more rich in hydrogen, right? So anti-Markovnikov rule is just opposite to Markovnikov rule. In this case, rich does not become rich. Rich does not become rich. Please remember this, rich is in context to total number of hydrogen, right, on the carbon. That is, hydrogen goes to the carbon which has less number of hydrogens. This is anti-Markovnikov rule. If you are not able to see it, you will get that in the PDF, but you will be able to see this, right? Okay. So this is what we did. Now, anti-Markovnikov rule, it is important to have HBr plus peroxide. It can be H2O2, it can be R2O2. Now, H2O2, as we know, OO linkage leads to a peroxy linkage. So these are your peroxides. Whenever you see H2O2 plus HBr in a chemical reaction, understand that this will follow anti-Markovnikov rule. This will follow anti-Markovnikov rule. If this is carbon A and this is carbon, this should be CH2. I wrote it CH3. Please correct it. This is CH2. This is carbon A. This is carbon B. Now, as you see, carbon A has one hydrogen. It is poor carbon. Whereas carbon B has two hydrogen. It is rich carbon. Since we are following anti-Markovnikov rule, poor carbon gets hydrogen, rich carbon gets Br. This is only possible in presence of peroxide. HBr plus peroxide. So the product obtained here is carbon A gets hydrogen, carbon B gets Br. So the major product obtained here is carbon A gets hydrogen, carbon B gets Br. 1 bromopropane is major product when we add HBr to alkene in presence of peroxide. Whereas if we were adding normal HBr, 2-bromopropane was major product because we were here seeing the stability of carbocation. During Markovnikov rule or normal addition of HBr, carbocation stability is the major. Carbocation stability matters. Whereas during anti-Markovnikov rule, a free radical mechanism is followed. We aren't going into mechanism, but you need to understand this simple rule. The major product is according to anti-Markovnikov rule when we add HBr to H2O2. Also, you must remember this is known as peroxide effect. This addition is known as peroxide effect, and this peroxide effect is usually observed during addition of HBr. It is only observed during addition of HBr. If you see that HCl plus H2O2 is written, you must remember that if alkene is given, let us say propene is given, and here you see HCl plus H2O2. Please do not get confused that H2O2 is written, it will always follow anti-Markovnikov rule. H2O2 will give you in presence of H2O2, addition will happen via anti-Markovnikov rule only if you have addition of HBr to your alkene. If it is HCl, HI, anything is written and H2O2 is written, please do not get confused. You have to follow simple Markovnikov rule. The major product will be 2-chloropropane. I repeat, peroxide effect or anti-Markovnikov rule, while addition of HBr while addition of your hydrogen halide in alkene is only possible for HBr addition. Neither of HI nor of HCl leads to your formation of uh, haloalkane via anti-Markovnikov rule in presence of your peroxide. Right. So this is the NCERT question. You have to quickly answer me what will be the major product. As we can here see, this is HBr. HBr, nothing peroxide, no peroxide is written. You'll only follow Markovnikov rule if peroxide is not written. So the major product is this carbon has 2 hydrogen, this carbon has 1 hydrogen. Rich becomes richer according to Markovnikov rule. The product of first is rich carbon gets more hydrogen, a poor carbon gets Br. This is your normal Markovnikov rule. This is the major product of the first equation. Let's move to the second one. HCl is written, nothing else is written. Even if it H2O2 was written, you don't have to follow Markovnikov rule. Anti-Markovnikov rule. Even if H2O2 is written in presence of HCl, here a normal Markovnikov rule will be followed. This is rich, rich becomes richer, so this gets hydrogen. The product obtained in the second part is this. You add Cl, so this has to be Cl not Br. This is Cl. This is CH3. This is the major product. In part number third, you see HBr plus peroxide. It will follow in presence of peroxide and HBr. Anti-Markovnikov rule is followed. This is rich. So rich does not get H during anti-Markovnikov rule. So the product obtained is CH2. Poor one gets hydrogen and the rich one gets Br. Right? So peroxide effect is only in presence of HBr. If it was HCl plus peroxide, you have to follow normal Markovnikov rule, and this is very, very important. Okay. So let's move now to halogen exchange reaction. In halogen exchange reaction, either you take chloroalkane or bromoalkane, react with NaI. Sometimes you may see acetone written over it, because acetone, it should be triacetone. You have solvent. Acetone acts as a solvent. This is normal nucleophilic substitution reaction where RCl, NaI gives I minus. The I minus acts as a nucleophile, attacks carbon delta positive, removes Cl minus. This is substitution reaction where halogen Cl is being substituted by iodine, and this is normal your preparation of iodoalkane by halogen exchange reaction. The name of this reaction is Finkelstein reaction. You must remember that the reagent here used is NaI in presence of dry acetone. The Cl minus that has left will interact with Na positive to give you NaCl. Similarly, RBr will react with NaI in presence of dry acetone to give you Ri and NaBr, right? So here you can form iodoalkane, which was impossible while doing the halogenation process. Okay. So this was your halogen exchange reaction, and now how to prepare fluoroalkane. This is the Schwarz reaction. What you have to do is normal. Take your bromoalkane, react it with any of the reagent, for example AgF, Ag2F2, COF2, SbF3. You must remember all these reagents which are used while halogen exchange reaction, where your halogen Br is being substituted by F minus, and it forms fluoromethane, and AgBr is formed. Right? So this is your normal Schwarz reaction. These are your halogen exchange reaction. Now if we've come to alcohol, how to prepare haloalkanes from alcohols. These are few reactions. You have to remember these reactions. I'll give you a quick mechanism to all the reactions. First of all, let's discuss how to prepare alcohol in presence of HCl and ZnCl2. HCl plus ZnCl2 acts as a Lucas reagent. We'll be doing Lucas reagent test in alcohol chapter also. So let's understand what happens in first part. You take alcohol, react it with HCl in presence of ZnCl2. ZnCl2 acts as a catalyst. Alcohol has oxygen which has lone pair. HCl acts as acid. Acid-base reaction is one of the fastest reaction. So alcohol, the oxygen on alcohol donates its lone pair, grabs the H positive to form this. Now Cl minus, wait a second, yeah. Now Cl minus attacks carbon and removes water, and it forms RCl, which is a haloalkane, and water is formed. So this is one of the method to prepare alcohol, to prepare haloalkanes from alcohol. You simply react alcohol with hydrogen halide in presence of ZnCl2, and we'll be dealing with this more in chapter alcohol, right? Next is prepare alcohol presence of NaBr and H2SO4. The reaction mechanism is almost similar. This was the first part. This is the second part. You are reacting alcohol with NaBr in presence of H2SO4. As you know, H2SO4 is an acid. It gives H positive. Alcohol, again, the oxygen has lone pair. It grabs H positive, undergoes acid-base reaction. Oxygen gives lone pair, acquires positive charge. Now NaBr is a source of Br minus ion, which acts as a nucleophile, attacks R, removes water, forms RBr. Water is being formed, right? And Na positive combines with HSO4 minus, because H positive is lost from H2SO4, it will form HSO4 minus. Right? So this is quite easy reactions. This was the second part. In third part, fourth part and fifth part, I am telling you the direct way and the trick to learn the reaction. So when alcohol is treated with PX3, for example PCl3 or PBr3, what you have to do is form Rx, whichever the X can be. If you are reacting with PCl3, the chloroalkane will be formed. Now how to balance this reaction? You must remember that it has 3 halogen. PX3 has 3X. So you need 3 R's, right? So you multiply alcohol with 3 so that you get 3R. 3R combines with 3X to give 3Rx. Now whatever you are left with, combine that. Since 3R has combined with 3X, it has formed 3Rx. We are left with 3 oxygen, 3 hydrogen and 1 phosphorus. 3 oxygen, 3 hydrogen, 1 phosphorus reacts to give H3PO3. Also you must notice that the X can either be chlorine or bromine fluorination. PF3 and PI3 are not generally we do not observe this reaction with PF3 and PI3. We only use PCl3 or PBr3 with alcohol to prepare chloroalkane or bromoalkane respectively, right? So this was the way to learn the trick and balance the equation, right? Now alcohol if treated with PCl5, as you know, now you don't have to say that PCl5 has 5 Cl atoms, I'll multiply 5 with this. This would be wrong. This has another trick. What you have to do is, you must remember that 5 since it has 5 Cl, one of the Cl will combine with R to give you RCl. One of the Cl will combine with H to give you HCl. Since 2 Cl are already used, one has combined with R, another one has combined with H, we are left with 3 Cl. We are left with 1 phosphorus. We are left with 1 oxygen. They all combine to give you POCl3. 1 oxygen, 1 phosphorus, 3 Cl forms POCl3. So this way you can remember it. And also when alcohol is treated with red phosphorus and normal halogen like Br2 and X2, it gives you Rx. This is a direct reaction which you have to remember. And this is very important reaction. This is known as Darjan process. This is known as Darjan process, and this is one of the best method to prepare chloroalkane. Because whenever alcohol is treated with SOCl2, it forms RCl, but as you see the side products are SO2 and HCl. They both are in the gaseous state. Whenever a reaction mixture, when you are doing a reaction, you have received your main product. The rest of the side products, if they are in gaseous state, they are just they can be easily separated. You do not need extra equipments or extra funding to separate the reaction mixture. It is very important and very easy method to prepare your chloroalkanes from alcohols via reacting SOCl2 with alcohols, because the side products are gaseous state. We do not need extra things or extra efforts to separate the product from the side products. When if you see from the industrial point of view, if you observe that if we get a lot of side products, it requires extra efforts, it requires a lot of money, a lot of new equipment to separate those products, and it is not feasible to companies, because then a lot of funding will be required, right? So since SO2 and HCl are gaseous, are in gaseous state, RCl can be easily separated, because gaseous state, as you know, they are just free to move, they can be easily separated. You do not need to do extra funding to separate your main product, right? So this is one of the best way to prepare chloroalkanes, the Darjan process. So this was it. We have already completed your preparation of haloalkanes. Now we'll move to physical properties, but before test I need to understand how much have you understood, and it's time for your test now. So the first question of the quiz is coming up. You must be very alert to do the quiz, right? Okay, so the first question is this: you have to tell me that in order to prepare 1 chloropropane, which of the following reactants can be employed. You have to tell me how to prepare 1 chloropropane. If we wish to prepare 1 chloropropane, how will we prepare it? Please be cautious while marking your answers. Give your 100%. Okay, let's move to your next question. Next question says that anti-Markovnikov addition of HBr is not observed in. You have to tell me out of A, B, C, D, where will anti-Markovnikov rule fail? Okay, time up. Let's now solve these questions. I hope you have attempted it all right. Okay, so we have to prepare 1 chloropropane. That is, our aim is to prepare CH3, CH2, Cl from all ABCD options. So let's see what happens if you add propene. If you add HCl in propene in presence of peroxide, this is propene, and you are adding HCl in presence of peroxide, which is gonna be the major product. Please don't tell me you'll follow anti-Markovnikov rule, as I have already repeated. Anti-Markovnikov rule is only followed when you take HBr with H2O2. Even if in the question the reagent written is HCl or HCl plus H2O2, you normally have to follow Markovnikov rule. So here we follow Markovnikov rule. Rich becomes richer. Since this is rich, carbon will get hydrogen, and the major product will be 2 chloropropane, not 1 chloropropane. A cannot be your answer, right? If we check the option B, propene, CH3CH double bond CH2, when reacted with chlorine will form, this can be addition reaction, or if it is in presence of light, this can be this. This is allylic free radical addition. If we treat it with OH, this is not gonna be the option. But if we check this, propanol when treated with SOCl2, as we know, this is Darjan process. OH is gonna be substituted with Cl. You get 1 chloropropane as the major product, and this was the required product. So the correct option is option number C. Alright, so this is your way which you have to think. Okay. Now, anti-Markovnikov rule of HBr is not observed in. Now, if we check this, CH3CH double bond CH2. These two carbons are different. We can distinguish it as rich, as poor. Anti-Markovnikov rule can be followed when HBr is taken in presence of peroxide. It can be followed. If we take butene, here also we have two different carbons. One is rich, another one is poor. We can distinguish, we can follow anti-Markovnikov rule. If we take pent-2ene, 1, 2, 3, 4, 5 second. Since these carbons are different in nature, CH3, CH2, CH3, they are different. We can follow anti-Markovnikov rule, but in but-2ene, both the carbons are in the same environment. They are equivalent carbons. We cannot follow anti-Markovnikov rule. So the correct option would be but-2ene, option number C. So this was it. We have completed our preparation of haloalkanes from all the possible methods. Now in next class, which will happen on Monday at 10:30 a.m., we'll be discussing about the physical properties of haloalkanes, and we'll be completing our all previous year questions as well as NCERT questions, in text questions. And once we complete this chapter, we'll be dealing with back exercise also, because back exercise is really important to achieve a good marks in your board exams, right? So we'll meet you on Monday at 10:30 a.m. We'll be discussing physical properties. Till then,